Okay, year 13s, this is our next thing on numerical integration, and here we're looking at the Simpsons rule. And the Simpsons rule is quite similar to the trapezium rule, except instead of trapeziums, we're using parabolas. And so across three height intervals, we use one parabola to approximate our graph. So in this example here, even though we've got four intervals, we've got two parabolas showing that. And it actually reduces the inaccuracy because the curve follows an unknown curve more closely. And so it's got a very similar formula here that we use with all our y values, and the same increment formula as well. So we'll go through an example and you'll get the idea. Now I will need that, so I'll just copy that and I'll use that later on. I've already put it down there. Okay, so with this first example, we're simply given a curve that passes through a bunch of points. So we're not actually given an equation. And so what I want to do first of all is make up a table like we did last time. So there's our table, and we'll put in a bit there. Okay, so we'll start with our our intervals, what we call them. So y1 through to y6, 4, 5, and 6. And then we'll put in our x values. So that's just reading from our coordinates. So we've got 0, 1, 2, 3, 4, 5, 6, and then our corresponding y values. So 0, 5, 8, 9, 8, 6, 5. Okay, so now that we've got those values in a grid form, we can throw it into our formula here. And so we'll say that our integral from 0 to 6 of whatever our function is going to be approximately equal to 1 over 3 times our interval, which is going up in ones, times our first y value plus our last y value plus 4 times all of our, and you look at these are all our odd interval ones. So that's going to be 1 and 3 and 5. And then plus 2 times all our even interval ones. So that will be, now I've just written in the wrong ones there as well. So that should be 5 and 9 and 6. So all our even ones are going to be 8 and 8. And we don't count 6 because that's already been our last one here. So I don't know why sorry, this one here is our last one. So I've got 5 in for that. Yep, that's fine. Okay, so just 8 plus 8 for that one. Okay, so now that I've got all my values in here, it's just a matter of putting into my calculator. So I've got 1 over 3 times 1, so I don't need to write that, times 0 plus 5, so I don't need to write 0, plus 4 times, and then 5 plus 9 plus 6, and then plus 2 times my other ones, which are 8 plus 8. And then we'll close up all our brackets. And so we get 39 for this one. So approximately equal to 39. Okay, let's compare that. Well, we can't compare that to our actual. So we'll just leave it there. But suffice to say that the area under this curve will be approximately equal to that. Okay, I've got one more example to go over, which I'll do in the next video.